In this video, we will learn how to graph solutions to one-step inequalities. Solving inequalities is a lot like solving equations. We can add a number to both sides, subtract a number from both sides, and multiply and divide both sides by a positive number. Alright, let's get to solving and graphing some one-step inequalities. For our first example, we have r plus 3 is less than 8. To solve the inequality, we want to get r by itself. On the left side, we have r plus 3. Therefore, to solve the inequality, we will have to subtract 3 from both sides. On the left side, 3 minus 3 is 0, so the 3's cancel out. We are left with the inequality r is less than 8 minus 3. Next, we simplify the right side. 8 minus 3 is 5. Our solution is r is less than 5. Now let's look at how to graph this solution on a number line. Let's plot some points that make the inequality r is less than 5 true. This means our solutions include numbers smaller than 5, such as 4, 3, and 2. We could keep going forever. We could even plot decimal numbers in between the whole numbers. How can we possibly plot all those points? We will represent them with a ray. Where should our ray begin? Remember, we want numbers less than 5. This means 4.9 is a solution, 4.99 is a solution, and 4.99999 is a solution. But 5 is not a solution because 5 is not less than 5. So how can we show that we want numbers very close to 5 but not 5 itself? We will plot a point at 5, but we will use an open circle that isn't filled in. An open point indicates that 5 is not included in the solution set. Now we can draw a ray to the left that includes all the numbers less than 5. So here we have the graph for the solutions to the inequality r plus 3 is less than 8. Any value that we choose on the ray makes the inequality true. Let's choose one value to check, such as 1. If we substitute 1 for r in the inequality, we get 1 plus 3 is less than 8. On the left side, 1 plus 3 is 4. So now we have 4 is less than 8, which is true. Our next example is 6 is less than or equal to 2b. To solve, we'll get b by itself. Since we have b multiplied by 2, we will have to divide both sides by 2. On the right side, the 2's cancel out and give us b, and on the left side, 6 divided by 2 is 3. This gives us 3 is less than or equal to b. We can also read that inequality as b is greater than or equal to 3, so let's rewrite it with b on the left side as b is greater than or equal to 3. Let's look at that graph now. Our ray will start at 3. Is 3 a solution to the inequality? In this case, yes, 3 is a solution because values greater than or equal to 3 are solutions, and 3 is equal to 3. Here we will plot a closed point at 3 by filling in the point. A closed point indicates that the 3 is included in the solution set. Now we need to draw a ray. Numbers that are greater than 3 are to the right of 3. We will now draw our ray to the right. This graph shows all the solutions to the inequality 6 is less than or equal to 2b. Before we move on to the next example, there's one more important thing to remember. When we multiply or divide by a negative number on both sides of an inequality, we must reverse the direction of the inequality sign. Let's try it and see why. Let's compare the numbers 2 and 5. 2 is less than 5, so we would write the inequality with a less than symbol. What if we multiplied both sides of this inequality by negative 1? Then 2 would become negative 2, and 5 would become negative 5. Now, is negative 2 less than or greater than negative 5? On the number line, negative 2 is farther to the right than negative 5, so it's actually greater than negative 5. We will use a greater than symbol to write our inequality. Negative 2 is greater than negative 5. The inequality symbol reverses directions from less than to greater than. So whenever we multiply or divide both sides of an inequality by any negative number, we also need to reverse the direction of the inequality sign. Let's apply this rule in our next example. We have t divided by negative 4 is greater than or equal to 1. Since we have t divided by negative 4, we will have to multiply both sides by negative 4. What is the rule when we multiply both sides of an inequality by a negative number? We need to also reverse the direction of the inequality. So let's write the greater than or equal to symbol as a less than or equal to symbol. Now we can simplify. On the left, negative 4 divided by negative 4 is 1, so the negative 4's cancel out and give us t. And on the right side, 1 times negative 4 is negative 4. This gives us t is less than or equal to negative 4. Let's graph this solution. Negative 4 is a solution because negative 4 is less than or equal to negative 4. We will use a closed point at negative 4. Numbers that are less than negative 4 are to the left of negative 4. We will draw a ray to the left. The graph now shows the solutions to the inequality t divided by negative 4 is greater than or equal to 1. Let's look at one last example. Negative 15p is less than negative 45. We have p multiplied by negative 15, so we will need to divide both sides by negative 15. Do we need to reverse the inequality sign? Yes. We divided by a negative 15, so we must reverse the inequality sign. On the left side, the negative 15s will cancel and give us p, and on the right side, negative 45 divided by negative 15 is positive 3. We get p is greater than 3. Let's graph this solution. Here 3 is not included because 3 is not greater than 3. So we will plot an open circle at 3. We have p is greater than 3, and numbers to the right of 3 are greater than 3, so our ray will go to the right. Now that we've seen some examples, you know more about graphing solutions to inequalities. When we have a less than symbol or a greater than symbol, we will use an open point. And when we have a less than or equal to or a greater than or equal to symbol, we will use a closed point. You're now ready to try some on your own.